Hello, everyone. This is, I believe, lecture 35. Hope I'm right. I think it's lecture 35. And we are, this is also third lecture on tort law, the law about the accident. As I have previously advertised, this tort law is involved with some calculations. And some economist students like you in department economics would like it because finally I will do some calculation. But some of you may not like it because maybe they want to have a verbal expression. They prefer it more than mathematical calculations. But anyway, it's inevitable, so just accept it. And this first part I'm going to explain right now is not very tough. So if you just patient enough, whatever your math background is, probably you can follow it. But without this first step, what I'm going to do probably in the next lecture, very deep calculations and things like that, you might have a problem. So please make sure you understand what I'm going to explain to you. Very simple once again. Social cost of accident. There's a car accident. Or when you're driving a car, what is the cost? Actually, okay. Anyway, I just realized that this should be social cost of precaution. But anyway, when you are driving a car, there are two costs. Of course, you can go many places that you cannot go when you have to work. But now you have a car, you can drive there. The social cost, number one, but you have to be careful. Okay. Oh, I'm sorry, I missed the first one. Okay, the social cost of accident. There are several components of concerning calculating social cost of accident. P is the probability of accident. Okay, when you drive a car, probably you will get an accident. For me, I drove it like almost 30 years. I bumped once or twice. Not serious. My wife bumped 3 times, I think. My wife is more prone to bumping. I'm more prone to like a speed limit kind of thing. But anyway, speed limit kind of thing is not the probability, but the accident does not happen all the time. Actually, that's very rare, but it's not zero. So P means the probability of accident. Of course, when the accident happens, let's come to A first. Money value of the harm from the accident. When I drive a car, I bump Mr. Kim's car, and Mr. Kim car is broken. My side mirror is broken. My car's bumper is broken. Kind of my car's window is broken. So together, the cost of fixing my car's window and the side mirror of Mr. Kim's car. That's the damage. If someone got hurt, human being got hurt, it can be very big. But anyway, there is an accident. Then because of the accident, you would have a monetary cost for that because you drive a car. P, the probability that accident happen. The accident may never happen. Some drivers like that, they never experience any accident. They must be very careful, very skilled. But some people has more frequently. But anyway, X is precaution level, which means how careful you are. Okay? How careful you are. W is the cost of precaution. What is precaution? You have to slow down, you have to abide by the traffic signal and things like that. You should not change the lane illegally, kind of thing. Okay, so that is precaution. So precaution has many various things, but vaguely, like we abstractively, we will think it as X. As X increases, the cost of precaution increases. So W is the unit cost of precaution. And naturally, when you think about X, the precaution, and P, are they related? Of course. Otherwise, why you are being careful? So when you are driving, you are careful, you're a careful driver, your probability of accident drops. So P is a function of X, and as X increases, P decreases. In other words, if you differentiate P with X, that has negative value. Hope that this is okay with you. The derivative differentiation, which means here, dot, means the slope. So what is the slope of P when X increase? Because X increase means you're more careful, then the P probability of accident decrease. That is why the slope of P concerning X is decreasing, which means negative slope. That's why this value is negative. Another very important terminology, okay, I have to show you, is the terminology injurer and victim. Okay, we are going to divide it into two parties. Okay, there are only two. This is a little bit restrictive. In real life, it might be a little bit different. But to simplify, I'm going to assume that there are injurer and there are victims. So the driver hit a person, pedestrian, that the driver is injurer, and the person who was hit by the car is a victim. Okay? And when we are talking about precaution, the driver obviously should be careful in order to decrease the probability of accident. But sometimes the victim should be careful too. I mean, there's the signal says red, the pedestrians, you should not cross the road right now, but you do. Or drunken driving is a problem, but when you go outside at night, some people are walking, but they are so drunk, and they do not know where to go and things like that. Then they are prone to accident with higher probability. So later we are going to talk about the precaution of injurer as well as the precaution of victim. Oh, I should change it to V. I'm sorry. What was I thinking? So XI, X, not J, XV, and WI, WV, which means the cost of precaution might be different. Might be same, might be different. Anyway, that's the notation of things we are going to do. Okay, I was a little bit quick in explaining this, but think about it. Maybe listen to the lecture one more time. The PXWA, they are the necessary element to notify the social cost. So social cost of accident. Finally, first of all, it is composed of two parts. Cost of precaution. When you are careful, you cannot go somewhere quicker. You are more like tired because you look around whether something happens. And expected cost of accident, which means the accident might actually happen. It happens. It's a hell. I mean, you have to spend time and money on that. So together, they are the component of social cost. So basically, the unit cost of precaution multiply the precaution, W multiply X, that is cost of being careful, cost of precaution. PX, the probability of accident, A, the damage from the accident. So that is expected cost, expected damage from the accident. So together, I hope everybody agree, makes sense, that is social cost. Because we divide it into two parts, look at the first part. If the precaution level increase, which means people are more careful, then the cost of precaution would increase. I mean, you're careful, you're more tired. I mean, you check your car more often, go to the repair shop more often and checking, that costs. And you are slowing down when you are driving, then the getting to school usually takes 1 hour, maybe 1.5 hours because you are slowing down, being safe. So being safe has a cost. So the WX would increase. What about P multiply A? Because the probability of accident would decrease, PX would decrease and A is fixed. Therefore, PA would decrease. So as X increases, the first part WX increases, PA, the second part, decreases. That is the characteristics of social cost function, equation. Okay, now we have a graphic demonstration. Okay, I draw it with my hand. Not very pretty, but hope that it's understandable, help you understanding. Then it serves its purpose. Social cost. Once again, keep in mind that social cost WX plus PX multiply A. Number one, what is WX? The graph 3. 3, it is linear. Okay, it doesn't look very straight, but it should be a straight line from 0, starting from 0. So, I forgot. The x-axis is x, which means precaution. So this is precaution. What about the perpendicular axis, y-axis? That's cost. So the cost and precaution. The precaution level x, depending on the x, how the cost changes. That's what this graph is all about. So if x increases, WX, the cost of being careful increases. As we already know, as x increases, the expected damage or cost from accident decrease, like this number 2 graph, number 2 line. And it doesn't have to be linear because we do not know what PX is, but anyway, it goes down. So graph 3 and line 3, line 2 are in a different direction and they are destined to cross once. And we know that the social cost of accident is adding up graph number 3 and graph number 2. So when you add up, it's going to be something like line number 1, and that is social cost graph. Okay, so this is just social cost. And do you want to maximize your cost or do you want to minimize your cost? I think we want to minimize the cost. The profit or happiness should be maximized, but the cost should be minimized. So this seems to be the minimum point. Okay, if you are confused a little bit, the crossing point does not guarantee to be the minimum point. Okay, so if you think it over a little bit, when these two graphs cross each other, the minimum of the added up social cost graph does not have to have a minimum here. Minimum can be anywhere, the left side, right side. I just draw it on the right side. So, at this minimum point, what we are interested in is how can we get this minimum cost? The minimum cost means efficiency. The result is the efficient result. So how can we get there? When people in here, the only person who should be careful is the injurer. When the injurer or driver of car is this much careful, not more careful, not less careful, only X star. So X star means optimal level of precaution from now on in this lecture. Once again, if you are less than X star careful, there would be many accidents. If you go left side, the PA would increase, which means there will be more accident. If you go to right hand side, the PA would decrease, but cost of precaution increases. You are being too careful, in short. So we don't want that either. So X star is the optimal precaution level, and all this total law I'm going to teach and you are going to learn is how can we achieve X star? How can we make the injurer, the driver, to choose X star? If the Korean government calculated the car's speed should be optimal at 45 kilometers per hour, how can the government force the driver of Korea to drive exactly at 45 kilometers per hour? That is the purpose of total law. It's not like I will get rid of any kind of accidents like that. If you get rid of all kinds of accidents, the simple way I mentioned again and again, get rid of a car. The car is, car is banned. If you want to get rid of drunken driving, like driving under influence, what can we do? Get rid of all alcoholic beverage, beers and soju and whiskey and wine. If you drink wine and beer, you're killed. Then nobody would drive under influence because they just drink wine, they would be hanged. So, but we know that that's too much. I mean, we don't have to go that extreme. So, so we allow drinking alcoholic beverages, but we just simply do not allow people drive when they drink alcoholic beverages. Of course, some people are careless, they still drive, so that there would be more accident than totally banning any alcoholic beverages. But then the effect is so small, but people's happiness from alcoholic beverages, which I do not know, I don't drink alcoholic beverages, but I have no idea why they are happy. But we, the government, do not want to get rid of the happiness people are getting from alcoholic beverages. Okay, so we have to be in the middle. We are not like very like theory oriented, like strong believers of something. Like we want to find out whatever is best for the people, and this X star is okay. Strict liability. Strict liability, once again, if somebody got harmed and somebody caused it, I drive a car, I hit Tom, then I'm injurer. Tom is a victim, and I hit Tom. Okay, so and Tom got harmed, and I caused it. Then that's a strict liability. So which means is whenever there is a accident, all A, the damage from accident is a responsibility of injurer. So if you are an injurer who choose X, what would you think? You think, oh my God, if there's any accident, it's gonna be PA, and the PA is my cost, nobody else's cost. If the government says, oh, there's an accident, oh, car drivers, they are busy. Why were you hit by your car? So Tom, you are responsible. Then all of a sudden, this PA would disappear, only Wx would be my cost, something like that. So, let's think about that. What if the government says when car hit a person, the car driver doesn't have to pay anything. It is the fault of the person who was hit by a car. Then this PA part would not be the responsibility of the car drivers. As a result, the car driver only worry about Wx. I mean, you are careful, the cost is yours. But then when you hit someone, then you don't have to pay anything. So in that case, the car driver injurer's cost function would be Wx. And you want to minimize, as a driver, Wx. How? X is 0. X is 0 means you're totally careless. X means being careful. Your carefulness would be 0. So if you drive a car and whenever there's an accident, you don't have to pay, then people would drive like crazy. That's what this means. But in strict liability, all the accident cost would be on the driver. Then the driver would think, okay, the PX, WX, they are my cost. So this line number 1, curve number 1, is now the driver's or injurer's cost, and the injurer want to minimize it, and he will choose X star. So, social efficient result. Hope you can think it over and understand this graph. Negligence. What's the negligence? Okay, negligence means if you are careful enough, you are a driver, you hit Tom, Professor Han, you hit Tom, but when you are driving and hit Tom, you are careful enough. Your precaution level X star is bigger than the social optimal level. For example, Professor Han, the speed limit is 50 kilometers per hour. And then when Professor Han hit Tom, he was driving 40 kilometers per hour. So 50, 40, 40 is smaller, but obviously he was more careful. So this is 50, you drive 40, you are very careful, more than enough careful, then you don't have to pay this PA because obviously that's Tom's fault because you didn't do anything wrong. Therefore, when Professor Han's X was above X star, the government does not ask Professor Han to pay PA. So the only cost for Professor Han is WX. But if he was less than X star careful, not careful enough, in other words, negligent. If I was negligent, then not only WX, I should be responsible for PA until this point. So the left side of this X star, my cost would be like this. So in the negligence rule, under my cost would be left side of X star, the two graphs together, right hand side, only WX. Obviously, the minimum point is here. It's not like smooth graph, it's kinked. But anyway, this is the minimum point. And once again, what X star, X I should choose, how careful I would be, X star, because that gives the minimum. So, if you go back, the social cost would be minimized at X star. Under strict liability, the individual injurer who choose X, cost line is same as social cost, so he will choose this. Under negligence rule, it's now changing like this red graph, okay, sharp edges, but still the driver or injurer will choose X star. So in this case, everybody happy. You don't have to worry about whether we should have a strict liability or negligence rule because both would guarantee the X star, which is socially efficient level of precaution. In the next lecture, I'm going to show you the same thing with calculations. See you soon.